Hello everyone, welcome to the series of session on dynamics of machinery. So now we'll be discussing on unit number 3, that is 2 degree of freedom system, free vibration. So under this video we'll talk about introduction to 2 degree of freedom system. So the learning outcome is student will be able to understand the vibrations in 2 degree of freedom system. Also they will be able to write the equation of motion for a given system. So let's talk about 2 degree of freedom system. So here is the diagram in which you can see this is the base and there are the two masses which are attached to the two springs. M1 is attached to K1, again K2 is attached to M1 and M2. Now X1 is the displacement of mass M1 and X2 is the displacement of mass M2. Now in this case X1 is required to specify the motion of this mass M1, whereas X2 is required to specify the motion of mass M2. So as there are two coordinates, these are the two independent coordinates now. So as these two independent coordinates are required over here, so this system is nothing but the example of 2 degree of freedom system. So as we know that degree of freedom is nothing but number of independent coordinates required to specify the system. So here x1 and x2 are the two independent coordinates which specify this system. So let's see the motion of mass m1 and m2. So this is m1 and this is m2. So here you can see the displacement of m1 is less and displacement of m2 is more. And in this case both the masses are moving in the same direction. Whereas in this second animation you can see this is M2, this is M1. M1 is displaced more than the M2 and again both the masses are moving in the opposite direction. So here you can compare the both, that in this masses are moving in the same direction, whereas in this masses are moving in the opposite direction. Now why such happens? So now in case of 2 degree of freedom system, as there are two masses, so we have to draw an FBD, that is free body diagram of two masses. So these two masses will give you two different equations. And in every equation there will be both the coordinates x1 and x2. So as there are two equations, now these two equations will give you the two natural frequencies. So when the initial excitation is given to this system, then the system will vibrate with one of this natural frequency. Now body vibrates in such a case at second natural frequency. So here you can say that the 2 degrees of freedom system has two natural frequencies and these two natural frequencies gives you the different mode of vibration. So this is the first mode in which the bodies are moving in the same direction, whereas this is the second mode where body is moving in the opposite direction. So the conclusion of 2 degree of freedom system is it requires two independent coordinates to specify the motion of the system. Then it has two equation of motion. Now as I told you that in both equation there will be x2 and x1. So as both the coordinates are there in the equation, so this equation is called as coupled differential equation. This name is coupled because both the coordinates are there in the equation. What is that? We will see. And then again 2 degree of freedom system have two normal mode of vibration at a particular natural frequency, or you can say at two natural frequencies there are two normal mode, and that is nothing but called as mode shape. So here are the examples of 2 degrees of freedom system. So here is the motor and the generator. So motor will act as one rotor and generator will act as a second rotor, and they are attached to the shaft. So if K1 and K2 are the stiffness of the shaft attached to the motor and the generator respectively. So here you can say again there are two masses and the spring. So this is the example of 2 degree of freedom system. And again same over here, this is nothing but the anvil over here is one mass and foundation block is acting as a second mass. In between anvil and foundation block there is a elastic pad which will act as a damper as well as it will have some stiffness. And similarly foundation block, in that there is a soil, so there will be some damping due to soil and stiffness of a soil. So this how the real life applications are converted into mathematical models. Now let's have one look on this diagram in which there are three springs having stiffness K1, K2, K3. K1 is fixed at one end and K3 is fixed at one end. K1 is attached to M1, K2 is attached to M1 and M2, and whereas K3 is attached to M2. And other end is fixed. Now this is the equilibrium position of mass M2 and this is the equilibrium position of mass M1. So x1 is the displacement of mass M1 and x2 is the displacement of mass M2. Now assume that we are pulling this mass in the downward direction. Acceleration is in downward direction. So acceleration is given by x1 double dot for M1 and x2 double dot for M2. So this is the displaced position. So now our task is to draw the free body diagram of mass M1 and M2. So first we will talk about M1. Now as M1 is moving in the downward direction, inertia force will be opposite to the acceleration. So M1 x1 dot in the upward direction. Now this K1 will resist the motion. So K1 x1 and K2 K2 into displacement. Now the displacement of K2, it depends on x1 and x2, both the parameters. So assuming that x2 is greater, so x2 minus x1 will be the total displacement of K2. So this force is written as K2 into x2 minus x1. So now next task is to write the equation according to D'Alembert principle, which is nothing but, or the formula is summation of inertia force plus external force equals to 0. So inertia force is m1 x1 double dot and these two are the external forces. So m1 x1 double dot plus k1 x1 and this k2 force is in opposite to this 2. So minus k2 in bracket x2 minus x1 equals to 0. So by rearranging these terms, so m1 x1 double dot plus, now taking k1 from over here and k2 into x1 over here. So k1, this minus into minus gets plus, k1 plus k2 in bracket x1 minus k2 x2 equals to 0. So this is nothing but the first equation of motion. Now you can see in this equation there is a term x1 as well as there is a term x2. Hence these equations are called as coupled differential equation. Now next we'll talk about mass M2. Now here M2, again its motion is in downward direction, so inertia force in upward direction. Again K2 force will act in upward direction. This and this component will resolve each other. And again assuming that x2 is greater, so x2 minus x1. And also this K3 will get compressed. So it will try to restore, or this mass will try to reach at equilibrium position. So K3 x2 in upward direction. So now writing the equation according to D'Alembert's principle, m2 x2 double dot plus K2 in bracket x2 minus x1 plus K3 x2. All the forces are in same direction, so all are positive, equals to 0. So now rearranging the terms, now m2 x2 double dot plus, taking this first and this, taking x2 term first. So K2 plus K3 in bracket x2 minus K2 into x1 equals to 0. So what you can do is, if there is x1 over here, then first write the term x1. And if there is x2 over here, then it's better to write second term as x2. Doesn't matter if we are writing first k2 x1, but just for simplicity, if there is x2, you can take x2 as first. So now this is nothing but the second equation of motion. So again in this, there are two terms, x2 and x1. Hence this equation are called as coupled differential equation. So these are the two equations which we have got from the 2 degree of freedom system. So if there are 3 masses, so the numerical will convert into 3 degree of freedom system if 3 independent coordinates are required to specify that 3 masses motion. So in that case, there would be 3 equation of motion. As the number of independent coordinates increases or number of masses increases, number of equations will increase and number of natural frequency will also increase. So as there are 2 equation of motion, so 2 natural frequencies, and there will be 2 modes of vibration which we have seen. I hope you have understood. Thank you. For any queries, you can write a mail on my email ID, or you can also write in comment box. And if you have liked my video, kindly like, share and subscribe.